Hi, my name is Bruce Sam, the Head of Developer Relations here at Partisia Blockchain Foundation. And today we are joined by two special guests from Partisia. And we're here to talk about the birthplace of Partisia, how it got started, what MPC is, and how we differ from other zero-knowledge technologies that are out there. So if you guys wouldn't mind introducing yourselves.
Sure. My name is Anders Dalskov. I'm a cryptographic engineer at Patricia. Has been here for 3 years now. Did my PhD studying MPC from like a more theory point of view. So it was super exciting to get to work in a company that now actually uses this, what I consider like a cool technology in practice. But yeah, cryptographic engineer. I work with protocols. I work with our researchers who are also located here in Aarhus, coding, so doing engineering. But I also work a lot with like the cryptographic protocols we have and like developing those and specifying them and working together with the researchers that we have working for us and working together with us, I guess.
Thanks.
Yeah, I'm Emil Orloff. I'm principal engineer in Partisia. Have been with Partisia since 2017, where I was dragged in by the lure of multi-party computation and what it would be able to solve, and doing a lot of design work around the governance layer and how the blockchain works.
That sounds great. I'm really excited to talk to you guys about Partisia and Partisia Blockchain as a whole, but also delve into what really makes us, well, first of all, what is really MPC? And then what really makes us different than other MPC technologies that are out there? Because I think these days there's a lot of coverage in things like zero knowledge and MPC. And sometimes navigating in that world could be very complex and confusing, right? So maybe we should start off with who Partisia really is. How do we begin, and then how do we end up becoming a blockchain company?
Yeah, Partisia was founded in 2008 to try to commercialize multi-party computations. So they had the first commercial use ever back in 2008, which was a sugar beet auction, and since then it has gradually increased, and a lot of work has been done trying to move the technology forward.
So we started off in 2008, but blockchain really wasn't created, even known about, and until 2012.
Yeah, back then blockchain wasn't a thing for us. We were a purely multi-party computation company. It was hard because no one knew what it was, no one understood it. so it wasn't that much that happened back then.
Yeah.
But from 2017, where I joined Partisia, things began moving forward. And at that point, we also began looking into what blockchain was and what blockchain could do for us. And since multi-party computation is a distributed computation, where multiple nodes need to agree what they're doing, it went hand in hand with what blockchains can do. Because blockchains help us establish a shared truth, public shared truth. And then we know, okay, we're going to compute this, given these inputs from these parties. So that's why we began working with blockchains in the first place. It fitted perfectly together with the MPC technology.
Yeah. One of the things that I found interesting is like in the blockchain architecture, they always talk about transparency. And I think what we kind of bring to the table is really that privacy aspect into the blockchain, which really makes us unique, right? A very unique blockchain technology in the entire ecosystem. So maybe Anders, you could explain to us, if you could, at a very high level, what is MPC? What does it do, and how does it differ from other zero-knowledge technology that's out there?
Sure. So Emil put it like kind of nicely that MPC is really a form of distributed computation. So it's a technology that allows you to do some agreed upon computation. So everybody needs to agree on, we want to compute an average salary, or we want to do an auction or something like this. And then multiple people can all come with their inputs and then perform this computation. What makes secure multi-party computation, or what puts like the secure in, or why there is like a secure in front of the multi-party computation, I guess, is the fact that you can do this computation without compromising on the privacy of all the people who deliver their inputs, or compromising on the correctness. So you can, like, secure multi-party computation essentially gives you a guarantee that the computation was executed correctly, and it was done so without revealing anything about the inputs of the people who participate. And that's really where it, like, I guess, again, like, complements the blockchain well, nicely, where everything, of course, is public because everybody needs to see it. But it also, so it adds something there for sure, something that is not there if you just look at a blockchain by itself. But it also utilizes some of the nice features about the blockchain, where everybody can see what's going on, namely that now you have actually a medium where people can agree on what kind of computation to run, who will participate in it. And moreover, in particular, when you have like a proof of stake system as we have, you also have now a mechanism actually to punish people if they misbehave, for example. So really, like, I mean, now I'm sort of getting into where blockchain and NPC sort of fits together, but in my mind at least, it's like the blockchain sort of fills out the gaps that are missing there. Secure multi-party computation is simply a protocol for people to compute something together, but it doesn't tell you like who has to participate, what kind of mechanisms should be executed if you find out that people are not doing what they're supposed to in this protocol. How to pay people for participating, of course, how to establish what kind of computation to run, all of these things.
In your mind, like, where do we sit, and what is the difference between fully transparent and fully anonymous?
Yeah, it's a bit of a tough question. Because when I hear anonymous, I think, anonymity, that I cannot see who participates. And at least if you really want to like split hairs, anonymity and privacy are like two different things. NPC will give you privacy, it won't give you anonymity.
Okay.
Actually, like the whole reason we're using a blockchain is actually to make sure we can particularly specify who's participating. So it's like almost the opposite of anonymity. Like there's of course like an anonymous chains like Monero and Zcash and so on.
Right.
But what they do is like very different.
Yeah, we have never tried to be anonymous.
Yes.
It is not a goal to be anonymous. It's a goal to try to hide private information, but be able to utilize them in a meaningful way.
Well, why is being anonymous bad?
I don't think it's necessarily bad. It's just it's like a different issue in itself. I think if you want to have like a very good example of like where like anonymity and privacy are like two different things from the non-blockchain world, would be something like the Tor network, which is of course provides a lot of anonymity by the way that it routes messages and so on, but absolutely do not guarantee privacy unless you connect to a secure website. Like there's plenty of examples of people running like these exit nodes, like where you actually connect to the internet from the Tor network, that are completely insecure. And you can do all kinds of things there. You can monitor the network, you can see what's going on, you can read people's passwords and so on. Maybe you cannot see where this connection came from, but I can still see like their passwords, and I can still see their usernames, and I can still see their email addresses, I can still see what they're posting on the internet and so on. So that is an example of like where anonymity and privacy is like two different things. Usually when you talk about NPC, actually, like there's also a very, very clear divide between like anonymity and privacy, because you actually want to be able to talk about like it's these particular entities who participate in the computation. You're not interested, of course, in revealing or guessing or whatever anything about their inputs or like their private data, but you sort of need to be able to say that like it's this person who participates, not this person.
I think that's a fantastic explanation. To me, I was always thinking about privacy and anonymity, where anonymity really doesn't establish or help to establish trust. If I'm if I'm fully anonymous to you, and I say, hey, Anders, I have a car problem. I want to borrow $500 from you, right? If I'm completely anonymous to you, you're not going to borrow. You're not going to lend any money to that person. But if you tell me, well, okay, I'm going to lend you $500, but I need you to be fully transparent. I need you to give me every information about who you are, where you live, who your brothers and sisters, families are, how much you make, and what your credit history is. I may be like, well, I'm not 100% sure if I'm comfortable giving you all that information, right?
Yeah.
So to me, it's like fully transparent and fully anonymous. They both don't help to establish trust in the system. And I think that's where Partisia Blockchain really fits in, because it helps to use the blockchain to be able to establish trust. So in the industry right now, there is a lot of words, there's a lot of buzz about zero knowledge and zero knowledge proof, and that there's also now companies that are touting themselves as MPC, right? So maybe Emil, if you could explain to the viewers at a high level, what is the difference between the various different zero knowledge technology that's out there?
Yeah, the major zero knowledge stuff that are out there in the industry today is multi-signature wallets. So using MPC to do signatures, so your wallet don't have to stay on one device to protect your private keys. It's a very limited scope. It doesn't give you the expressiveness that the full multi-party computation does, that the Partisia Blockchain supplies, but it does solve a problem. So it's good to have MPC to do key orchestration out there, but we want to do so much more. We want to allow people to do any computation on data that is kept hidden.
What about things like zero knowledge proof? There's a lot of word about zero knowledge proof, and how does that differ from MPC as a whole?
On a high level, zero knowledge proofs allows me to convince you of something. So what I convince you of is establishing a fact. So I can prove to you that I'm over 18 years of age. But it's one fact I can prove to you. If we both want to give input into the conversation, it gets much more complicated. Because then we both have to prove something to each other. And if those things are correlated, it becomes very, very difficult.
And expensive, I assume.
Yes.
Yeah.
I guess you can view zero knowledge computation as actually like an MPC protocol, but it's limited to computations that just outputs yes or no. Like, I own my private key, for example. I will be able to convince you of that fact using a zero knowledge proof without actually revealing my private keys to you. So that's a fact. I own this private key or I don't. Like, if the proof I give to you, if that's convincing, then this computation that claims that I own my private key, returns yes, otherwise it returns no. But as Emil said, like this type of computation becomes very complicated when, for example, if me and Emil, for example, own a threshold key, so like we both have a share of a key that we can use to transfer coins from an account, but neither of us can do it by ourselves. If we want to convince you that we, own a share each that, together with combine into this key, then suddenly it becomes, or it can become a lot more complicated. And in particular, it becomes way more complicated if the statements are like very, very difficult or like very complex. Like, I know the input, or I know an input to this machine learning model that will output that yes, this is a beaver or something like this. And that becomes like very complicated. Or I own a secret sharing of a picture of a beaver for this particular model, something like this. For those, secure multi-party computation is way more suited. Also because it will now actually be able to tell you directly that it is a beaver. I don't have to, code that into the proof, so to speak.
Got it. Yeah. So then we discussed a little bit about the fact that there is a lot of companies that are out there that are, both saying that they're zero knowledge proof, but also a couple of companies that are talking about how they are, they have MPC. So maybe it's a good idea to talk about what makes us different than other MPC and zero knowledge technology companies that are out there.
So I think, of course, a lot of companies have sort of the same idea or like the same observation that we have, that blockchains are very transparent. There's a need for privacy in there. If you want to enable certain use cases that wouldn't be possible otherwise, and a lot of people approach this problem in many different ways. We choose MPC. MPC is a fairly old technology compared to blockchain for sure. As a theoretical science, it has existed since the 80s. It has existed since before zero knowledge proofs, for example, which grounds it very firmly in a lot of like established peer-reviewed research, as opposed to say solutions based on trusted execution environments, which on its face is like a very simple thing. You have a black box. This black box, you cannot look into it basically, but where the security of this black box is established not from like solid research. It's basically established from a trust in whoever manufactures the hardware, and this trust has to be sort of absolute to some extent.
So TE environments, something like secret network would be an example of that.
Yes. Right? And it also, again, this like trusted execution environments, of course, they have the same issue that zero knowledge proof systems have, is that they're useful if I know the entire secret, and that's the only secret in the system, and I'm also the owner of the trusted execution environment, because then I can keep my secret in this small black box and I can do computations on it without revealing anything about the secret or anything what's going on inside this box. As long as there's like multiple people who have a secret, as you would have in, let's say, an auction, for example, or in any kind of like statistics, like aggregated statistics, where you wish the people who provide the data for that you're aggregating over, you wish for that data to be kept, under the ownership of the original owners. Then it becomes like super complicated.
Okay.
And I even believe like somebody like Secret Network are mentioning that they wish to combine this TEE technology with MPC, exactly because you cannot do this with TEEs alone.
Got it.
And it's just like a side remark. That's also how you obtain like this multiple input facet in for zero knowledge proofs is essentially to combine zero knowledge proofs with MPC in some shape or form.
What about things like, and Emil, you brought up companies that are doing multisig as an example, right? So how does those type of companies differ from what we do?
Well, they have tailored MPC. They do MPC computation that does exactly one thing.
Okay.
While we are trying to make it possible for the end user to specify what they want to compute. So we are building a language and framework around the fact that you want to do private computations.
So it allows like customization. It allows so things like multi-sig companies, like Fireblocks as an example, their technology only allows for splitting up of private keys as an example.
Yeah, they allow splitting up private keys, and then they allow for me as the owner to come with what I want to have signed, and then I will get a signature back. And that's the only thing it can do. So if suddenly me and Anders both want to compute our average salary, or doesn't make sense for two people, but you get the point, right? Then we can't use that because we can give it something to sign and then we get a signature back. So what we are doing is we are creating a full platform that allows any computation. Okay. Essentially any computation. So of course at some point they get expensive, but any computation is possible.
Yeah, so it allows customization for the developers to customize their applications to tailor their specific business requirements or their needs.
Yeah.
Okay.
So there's a lot of value in having a generic platform that can do MPC, or a platform that can do generic MPC as we have. You can take a platform that can do any kind of secure computation and turn that into a threshold signature wallet if you wish to do so. You cannot really take a threshold signature wallet and turn it into a secure auction. That's a huge difference. It allows customization, flexibility for the developers. There are other companies that I've heard of that does
that claim that they do similar things. Things like Million, or maybe ALEC0 is another name that's been around in the industry. How do we differ from those types of generic MPC companies?
So I think again, like MPC is really grounded in like decades of research, and it means in particular that there is a very solid theoretical foundation for it, but also in particular within the last 10 years, essentially actually going back to the sugar beet auction that we've been part of, like way back in 2008. There's a ton of research that shows the practical aspects, or like that examines the practical aspects of MPC. It's very interesting to see how, or you can see how like secure computation starts as like a theoretical thing only, and then suddenly in the mid 2000s, end of like the 2000s, for example, the speed at which you can compute, say, an AES encryption, for example, just goes like through the roof. So now you can really do like a ton of things with MPC, and the fact that you can do, or all of these things you can do, are actually like has been shown in research, or has been shown in practical applications now. There's of course companies like Nilion, for example, that do something that is more, you could say, novel, like new, but these techniques are like not tested in practice.
Okay.
So it may look good like on paper, but it's very hard to see how it might actually be like generic and practical,
usable,
relevant, essentially. Yeah, exactly.
But as MPC has been around since 2008, there will be other companies that looks at the research and tries to do the same thing as us. Of course there will, because it's known, has been known for a long time how to do it. I think the point to stress here is that most of the first research done has been done with the researchers that are a part of our team.
So we're sitting here at Argus, right? And we talked about research papers, and we talked about how important it is to have practical use of these types of technologies. Can you tell us why we are here in Argus?
Yeah, Partisia was founded here in our office because the founding fathers are some of the researchers sitting at Aarhus University and doing research in MPC and doing some of the initial work on MPC back in the 80s. And they are still part of the team. They come around on a regular basis to ensure that what we're doing follows with the newest research, that it actually works, that we don't miss the small points that are the important points when doing crypto. Because you only need to miss small, minor detail, and then suddenly everything breaks apart.
Would it be fair to say that this is the birthplace of MPC?
I mean, you wouldn't be entirely incorrect in saying so, I think. It would probably hurt the feelings of a lot of like great researchers who are not based in Aarhus. But certainly a lot
one of the birthplaces.
Yes, for sure is one of the birthplaces of cryptography. Actually, one of the researchers that we have on the company, Ivan Damgaard, who's sitting in an office like 100 meters that way, basically. Just recently got an award from a distributed computation conference for one of these like very first MPC papers that he was a part of back in the 80s. So one of the first papers that describe how to do secure multi-party computation with like unconditional security, which is a technical term, but still. And which for sure in 88, I think, was, nobody had thought that you could actually use this in practice.
Yeah, wow. That's it's really exciting to be a part of a company that is not just the forefront in the technology, but also, almost like a birthplace for this amazing technology that we think will drive the next evolution of blockchain. So, Anders, Emil, I want to thank you guys for taking the time out to have this awesome discussion. Looking forward to another time where we can delve a little bit more deeper into maybe the technology, the very deep technology aspect of it. I want to thank the audience for viewing this video, and we will see you guys again soon. Thank you.